Welcome to chemistry classes by Vijay Kumar Sethi, class 11th chemistry, unit 4 chemical bonding and molecular structure. And in this video, we will discuss about hybridization of carbon in ethane, ethene and ethyne. First come to hybridization in ethane C2H6 molecule. Okay, as we know, hydrocarbons can be classified into two categories, saturated hydrocarbon and unsaturated hydrocarbon. In saturated hydrocarbon, there is carbon-carbon single bond. In case of unsaturated hydrocarbons, there is carbon-carbon double bond or carbon-carbon triple bond. Now in this C2H6, this is a saturated hydrocarbon and there is a carbon-carbon single bond. And we also know then single bond means sigma bond. Okay, and when double bond is there, 1 sigma and 1 pi. If triple bond is there, 1 sigma and 2 pi. In case of carbon molecules, that is hydrocarbons or organic compounds, the hybridization of carbon is decided by the number of sigma bonds. Okay, if 4 sigma bonds are there, hybridization is sp3. 2 sigma or 3 sigma bonds are there, hybridization is sp2. 2 sigma bonds are there, hybridization is sp. Okay. Now in this structure, this is the structural formula of C2H6. You can see that this carbon and this carbon, both carbon are forming 4 sigma bonds. That's why each carbon is sp3 hybrid. Now, how this sp3 hybridization? In ground state, this is the electronic configuration, and to form 4 sigma bond, there should be 4 half-filled orbital. That's why one of the electron from 2s is excited to the 2p orbital, and this is the electronic configuration of carbon atom in excited state. Now, these 4 half-filled orbitals undergo intermixing and form 4 sp3 hybrid orbitals. Is it clear? That is, each carbon is sp3 hybrid. Now, this carbon-carbon bond is a sigma bond, and this bond is formed by overlapping of sp3 hybrid of one carbon with sp3 hybrid orbital of another carbon. Okay, and now remaining 3 sp3 hybrid orbital of each carbon overlap with the 1s orbital of hydrogen atom and again form 3 sigma bonds. In this way, total number of sigma bonds are formed. 1 sigma bond between carbon-carbon by sp3 overlapping, and 3 sigma bond by overlapping sp3 of carbon and 1s of hydrogen. Okay, same this carbon is also formed. You can also represent this structure. This is carbon-carbon sigma bond, and these are the carbon-hydrogen sigma bonds. Okay, that's why we can see carbon-carbon bond is formed by the sp3 overlapping, and that is also the sigma bond. And each carbon hydrogen bond is sp3h sigma bond. In ethane, carbon-carbon bond length is 154 picometer and each carbon hydrogen bond length is 109 picometer. Okay, this is the hybridization of carbon in ethane molecule. Now come to hybridization in Ethene C2H4 molecule, and this is the structural formula of C2H4, and from this structural formula you can see there is a double bond between carbon-carbon. Double bond means one is sigma bond and one is pi bond. Now we can see that each carbon forms 3 sigma bond. 3 sigma bond means each carbon is sp2 hybrid. Okay, now let us see again carbon atom in ground state. This is 1s2, 2s2, 2p2. In the excited state, one of the electron from 2s will jump to the 2p and we will get this 2s is 1, and again in case of 2p singly occupied, each orbital is singly occupied. But for the sp2 hybridization, 1 2s and two 2p orbital undergo sp2 hybridization and one p orbital remain unhybrid. Is it clear? Now, these sp2 hybrid orbitals arranged in trigonal planar way. This one is. This is trigonal. This is also trigonal planar. Now, sp2 hybrid of this carbon overlap with the sp2 hybrid orbital of this carbon and form a sigma bond. And remaining two sp2 hybrid orbital of each carbon overlap with the 1s orbital of hydrogen atom and form sigma bond. Okay, in the same way, this is sigma and this is sigma. Okay, now each carbon contain this 2p unhybrid orbital which is perpendicular to the plane, and this is represented like this is unhybrid p orbital. Now this p orbital may be px or may be py because pz orbital is involved in the sp2 hybridization. Okay, now these unhybrid orbitals sidewise overlap and form pi bond. Okay, and as we know, in case of pi bond, electron cloud is above and below the plane. This is above the plane and this is below the plane. And this is sigma bond between carbon-carbon and this is sigma bond between carbon-hydrogen. This is also sigma bond between carbon-hydrogen. Okay, now you can also represent this one is, that is after forming sigma bond, the unhybridized orbital, it may be 2px or 2py of one carbon atom overlaps sidewise with the similar orbital of the other carbon atom to form weaker pi bond which consists of two equal electron clouds distributed above and below the plane of carbon and hydrogen atoms. You can again see this is diagram, and this diagram represents both formation of sigma bond as well as pi bond. This is hybrid orbital. Again remember, sigma bond is formed by the hybrid orbitals. Hybrid orbitals do not form pi bond. Pi bonds are formed by unhybrid orbitals. Okay, that's why this is sidewise overlapping between px of this carbon and px of this carbon and pi bond is formed. This you can also represent sigma bond along with the formation of pi bond. And again, in case of pi bond, electron cloud is above and below the plane. That's why this above the plane and this is below the plane. Okay, this is C2H4 molecule. Now come to hybridization is in ethine, that is C2H2 molecule. This is the complete structural formula of this is ethine, and again from this structure you can see there is a triple bond between carbon-carbon. One is sigma and remaining two are pi bonds. That's why you can see that each carbon atom forms two sigma bonds. Two sigma bonds means two hybrid orbital, and when two hybrid orbital is there, hybridization is sp hybridization. Okay, you can say both carbon atoms undergo sp hybridization, and when hybridization is sp, having two unhybridized orbital, that is 2px and 2py. Again you can see carbon atom in ground state 1s2, 2s2, 2p2. In excited state this is 1s2, 2s1, and each 2p orbital occupy one electron. Now hybridization is sp, that is 1s and 1 p orbital is involved. In this way there are two unhybridized p orbital. Now these two sp hybrid orbitals are oriented in a linear way like this. This is the carbon, this is sp, and this is also sp. In the same way for this carbon, this is sp and this is also sp. The carbon-carbon sigma bond is formed by overlapping of sp of this carbon and sp of this carbon. This is sigma bond, and one remaining sp hybrid orbital of each carbon atom overlap with the 1s of hydrogen atom and form sigma bond. Okay, that's why we can say Each carbon is sp hybrid. Carbon carbon bond is formed by sp sp overlapping, and this is a sigma bond, and each carbon hydrogen is also sp s sigma bonds. Now, each of the two unhybridized p orbitals of both the carbon atoms overlap sidewise to form two pi bonds between the carbon atoms. Now, this is formation of pi bond representing by this. This is 2px is sidewise overlapping with the 2px of the another carbon atom. Okay, remember it. 2px is overlap with the 2px. In the same way, this is 2py and this is 2py. This is overlapping. Okay, in this way, two pi bonds are formed by sidewise overlapping of 2px of one carbon with 2px of another carbon, and 2py of one carbon with 2py carbon of 2py orbital of another carbon. Okay, you can also see this diagram. In this, all sigma and pi bonds are represented. The triple bond between the two carbon atom is made up of one sigma and two pi bonds. Okay, this is sigma bond and these are the two pi bonds. This is formation of C2H2 molecule by sp hybridization. And now in this case you can say there are two pi bonds are there, and these electron cloud of each pi bond is above and below the plane, and that's why these pi bonds, electron cloud of these pi bonds can be represented like this. Okay, these two electron cloud above the plane and two electron cloud below the plane. And carbon carbon triple bond length is 120 picometer and carbon hydrogen bond length is 106 picometer. Okay. Now, after the discussion, how can you draw? In this video, diagrams are already drawn. But if you are asked to draw the diagram, then how can you draw? Let us see one by one. This is C2H6. Each carbon is sp3. Okay, sp3 means tetrahedral. Now let us see how will you draw these. This is one. Okay, and sorry, just a minute. You can draw this tetrahedral in this way. Now these are this is one carbon atom. Okay, the same way this is another carbon atom. This is a sigma bond between sp3 of this carbon and sp3 of this carbon, and this is 1s of hydrogen atom. Okay, this is C2H6. Now in case of C2H4, each carbon is sp2 hybridized. Now see, sp2 hybridized means that is trigonal planar arrangement. This is one carbon atom. And this is another carbon atom. And this sigma bond by sp2 overlap between two carbon atom, and this is overlap with the 1s of hydrogen atom. This is 1s of hydrogen atom. This is also 1s of hydrogen atom, and this is also 1s of hydrogen atom. Now each carbon atom has one p orbital perpendicular to the plane. This is p orbital. Okay, and these p orbitals sidewise overlap and form pi bond. This is pi bond. Okay, now in case of C2H2, Each carbon is sp hybridized. Sp hybridization means linear arrangement. This is sp hybrid orbital of one carbon atom, and these are the two sp hybrid orbital of another carbon atom, and this sigma bond is formed by overlapping of sp of one carbon and sp of another carbon atom, and this is overlap with the 1s of hydrogen atom, and this overlap with the 1s of hydrogen atom. Okay, this is sigma skeleton. Now each carbon has two unhybridized p orbitals. Now let us see. This is one unhybridized p orbital, and these unhybrid orbitals are perpendicular to the each other and perpendicular to the plane. Okay, if you say this is px and this one is py. Now in the same way, this is px and this is py. Now when you draw the sidewise overlapping, be careful, px will overlap with the px. Okay, now just see, this is px is overlap with this px. The same way, because in case of pi orbital formation, electron cloud is above and below the plane, that's why you have to draw like this. And py will overlap with the py. This is py and this will overlap with this, and this is overlapping with this one. Is it clear? In this way you can draw the representation, or you can represent the hybridization in C2H6, C2H4 and C2H2. Thank you.